Example 2.2 has us solving our first separable differential equation. It is a differential equation because it is an equation with a derivative in it, and it is separable because we can write this right-hand side, f, which has a bunch of x's and y's in it, as a product of a function of x and a function of y. Right, this h of y, we'll call that 1 plus y. This g of x, we'll call that the e to the x function. So our right-hand side of the differential equation is a product of x's and y's. We can separate the variables. I will copy down the original. And our first move is going to be to divide. Oops, I forgot my equal sign. We will divide this 1 plus y over to the other side. So I have that dy over there with a 1 over 1 plus y. And I will move this dx over there to the e to the x. So I've separated my variables, and now I can integrate both sides. All right, on our left-hand side, we have a trivial substitution. This becomes the natural log of 1 plus y. And on the right-hand side, the integral of e to the x is itself e to the x. I have a plus c on both sides, which I will just collect onto the right-hand side and combine it into just a single constant, c. So there we have an implicitly defined solution for the differential equation. We've integrated and we've gotten rid of all of our derivatives and recovered information about the y value there. Our last job is to solve for the function y explicitly. So we'll take the above relationship and put it into the exponent of the exponential function. Right, to get rid of that natural log, we have e raised to the e to the x plus c, which I will rewrite as e to the x times e to the c. That constant c is just a constant, so e to the c is another constant. I'll just call that another c. I'll just group that into another constant. Okay, last thing to do is to subtract the 1 over to the right-hand side, which gives us y is equal to a constant times e to the power of e to the x minus 1.